So in question 4, what got a lot of people hung up and maybe just intimidated was that function was defined as an integral, which is a little bit non-standard, but you saw some of that in the homework. At least one of the questions in the homework was defined that way. The key is to understand that it actually makes life easier when what you want to do is differentiate it. So we had x as a function of y in that problem. I've written this sort of in the standard way that you see the fundamental theorem of calculus. The fundamental theorem of calculus said define a function big F so that it's defined as this integral. And then the derivative returns this integrand evaluated at x. And here's the idea. This is actually the thing that Newton and Leibniz get all the great credit for, is this synthesis of differentiation and integration. You have a function defined as the integral of this other function. When you integrate and then turn around and differentiate, the two processes cancel each other off. That's what we're seeing here. In this special way, they are inverses of each other. Just like when you add and then subtract the same amount, or square and then square root, at least for positive values, they're inverse operations, right? So they should cancel each other off. Well, this integration did something to little f, but then differentiation undid it when we're back to little f. That's the idea. So when you were looking at that problem, I believe it was x of y was defined as the integral from 0 to y of the square root of secant to the 4th minus 1 t dt. So this is really a fundamental theorem of calculus thing. So when you take the derivative of that function, it just undoes that integration, and you end up with this thing, but now with a y in it. So, and that was precisely what was the big hang-up for everybody on this problem, was not recognizing that fundamental theorem of calculus applies. Part 1, this idea that differentiation sort of undoes integration under the right circumstances. And then from there, when you square this and set up the integral for your length calculation, the integral turned out to be almost trivial. So make sure you understand that this part of the fundamental theorem. This was also key to when I derived the arc length differential. We had the arc length function, and then I took the differential of that. That invoked this idea of the fundamental theorem of calculus as well. So make sure you understand this concept. We don't use it near as much as part 2. Remember, part 2 is the one that everybody loves, because that's the one that says that when you integrate from a to b of little f of x, the way you calculate that is by taking its antiderivative. And that's the one we use all the time, right? We use this every time we do a definite integral, so we're all comfortable and familiar with this guy. But this is really the key concept as far as how Calc 1 and Calc 2 tie together. Differentiation and integration are inverse operations of each other. So make sure you're comfortable with this. If not, go back. This is all developed in Chapter 5. Take a look at it and let me know if you have questions.